All right, welcome back, everybody. Happy whatever day it is that we're actually doing this lesson. Lesson 3.3. Today, we're going to talk about fitting a line to data. So, the first thing that we want you to be able to do is to be able to write an equation to or a linear equation to a line if you're given some data. So one way of doing that is using this formula called the point slope form. The idea of this formula kind of tells you how you can go about doing it. If you're given a point, so if you're given the point x1, y1, we'll just call it, okay? And the slope is the letter b, then we can write the equation of a line using this formula. Y equals y1, so the y coordinate, plus the slope times x minus x1. So the points in here that we plug in number-wise is the x1 and y1 value, and b. X and y represent the variables, like y equals a plus bx. It's just going to look a little bit different. So we're going to start by using this formula. Then later on, we might convert it, okay, to the slope, what we call the slope y-intercept form. That's what we were using in 3.1. That's the y equals a plus bx. Again, this is where a is the y-intercept and b equals the slope. So there are two forms that we like to use, and we interchange those two forms quite a bit. All right, so let's take a look at some examples here today. All right, so number one here says, write an equation in point slope form for each line, then determine the y-intercept. So I'm going to start by using this formula that I just wrote there in pink. So here, notice how they give you the slope. So there's my b value, and they give me the point x1, y1. So I first start off by just making sure I can plug these values in. So I go y equals, the y1 value is -3. So I go -3 plus my slope, which is 2. Then I have the x value minus the x1 value. So subtract 4. So I got my equation in point slope form. Now the second part of this problem asks you to find the y-intercept. To really find the y-intercept, we want to use that form right there. Y equals a plus bx. So what I need to do is I need to do some algebra skills, use some algebra, combine like terms, and get it so that it equals y equals a plus bx. It's close, but I still got to do a little bit of work. So what I have to do is I have to distribute. So if y equals -3 plus 2x, 2 times -4 is -8. Then I combine like terms. So I have y equals -3 and -8 make it -11 plus 2x. Now it's in slope y-intercept form. There's my y-intercept, -11. Okay. So hopefully you found that to be relatively easy. If not, follow this one, as this one's done exactly the same way, just different numbers. So here I have a slope of -3 and the point 2, so that's going to be my x1, and my y1 will be 5. So I plug this in to start. Y equals the y1 value, so 5. The slope is -3, so instead of plus, I go -3. In parentheses, x minus the x1 value, -2. So just like I did on the previous one, I need to distribute. So I get y equals 5 Negative 3 times x is minus 3x. Minus 3 times negative 2 is plus 6. Now I want to combine like terms. So I get y equals 11 minus 3x. So I have it in that form. Remember, the number itself is the y-intercept. So I get the number 11. All right, that takes care of the first two. All right, the next two. We're going to bring back some geometry words that we remember hopefully from our last year in geometry or the year before when you had geometry. The first word here says parallel. So it's parallel, and they give you an equation to a line and passing through the point 4, negative 2. So what's nice at least here is they give you the point x1, y1. The piece that they don't give you is the slope. So what you have to remember about the word parallel and slope is that it has the same slope. So what I can do is go to this equation and say, all right, the number in front of the x is the slope. There's my b. And since it's parallel, it must be exactly the same. So in essence, I have my slope right there. So now I can start to plug it in. Y equals the y1, sorry, I think I wrote y2 there, y1 value, so negative 2, then the slope, so negative 1/2 x, okay, minus the y1 value, the x1 value, misspoke again, luckily I caught myself, minus 4. Now that I got my equation, let's distribute and simplify. So y equals negative 2, negative 1/2 times x is just negative 1/2 x. Negative 1/2 times negative 4 becomes positive 2. Combine your like terms here. They cancel each other out. So I'm just left with y equals negative 1/2 x. Another way of looking at that, they add up to 0, so that's my y-intercept. All right, the last one. Now it says instead of the word parallel, it says perpendicular to the line, negative 1/2 x plus 5. So same line, passing through a slightly different point. So here's my x1, y1 again. And now I got to figure out what the slope is from this equation. What does it mean that for slopes to be perpendicular? Well, what it means is that they are, if slopes are perpendicular, they make a right angle, and their slopes numerically will be called opposite reciprocals. Opposite means you change the sign. So if it's plus, it becomes minus. If it's minus, it becomes plus. Reciprocal means you flip the fraction. So what it means here is, here's my original slope, negative 1/2. Well, the opposite makes it 1/2. Flipping it makes it 2/1, or the new slope is actually just 2. So as I plug this in, y equals the y1 value, which is 6. My slope now is 2 times the quantity. Sorry, I'm getting a little spinning wheel there for a second. And then it does a little slash on me, sorry. X minus a negative 2 makes a positive 2. Because again, a minus makes a plus. So now I can distribute just like I've been doing on the other ones. Y equals 6 plus 2x plus 2 times 2 is 4. 6 plus 4, now combine the like terms. y equals 10 plus 2x. So my y-intercept here is 10. All right, number 2 and number 3 are going to be our special lines. So this is kind of like a review of 3.1 a little bit. It says write an equation for the line with 0 slope. If it has 0 slope, that means the line's just going straight across. Well, that means it's horizontal. And a horizontal line has the equation, we remember, y equals a number. So the number that it equals here is 3. So the equation is y equals 3. Well, if I'm graphing that, y equals 3, remember that it actually does have a y-intercept, and it happens to be that value. So my equation is y equals 3, and the y-intercept is 3. Now the last one, undefined slope, passing through the point 9, negative 3. If it's undefined slope, that means the line is going straight up and straight down. That's a vertical line. So if it's a vertical line, that's in the form x equals a number. The number that it's going to equal in this case is the x-coordinate. So x equals 9. The y-intercept, remember, on vertical lines doesn't exist. So we get undefined. All right, so that was a lot of stuff there on the front page. Woo! All right, let's go to the second page. All right, last example here. So on number 4 here, it says the manager of a concrete hall keeps data on the total number of tickets sold and the total sales income or revenue for each event. Wow, we have tickets and then we have total revenue. It says set up the x and y axis and plot the data. So when I look at my x-axis, it looks like I have numbers going from just under 300 all the way up to a little bit more than 600. So this is what I'm going to do for my x-axis here. I'm going to use every 2 as a 100. So 100, 200, 300. So here's my x-axis. There's 400, 500, 600. If I need to, 700. For my y-axis, wow, it's going all the way up to 4,500, all the way down to about 2,000. So I might count by every 500s. So this is going to be every 2 is 1,000. I have to go up to at least almost 5,000. So now I'm going to graph each of these points. So I'll use a slightly different color here, red. So 448, so close to 450, up to 3357. I'm going to estimate where that point is. 601, almost 4,500, so about right there. 297, just less than 300, up to just barely over 2,000. 533 and 3784, about right there. 523, so a little bit, sorry, that point was 533, that was right. 523 and about 3,300, about right there. 493, 36, about right here. And then 320, a little bit smaller, 2353. So it's maybe about right there. So you can see that our data is pretty darn close to a straight line. It's not perfect, but it's pretty close. So what I want to do is find a line that describes the overall pattern of the data. So in part B, I have to choose 2 points that if I were to actually connect them, that describes the pattern. If it makes sense, try to choose the first and last point. Now, if I connect these, I'm just going to kind of roughly sketch these. You can see that the data fits that line pretty darn well. So I actually kind of like those 2 points. So I got to figure out where this point again is. Looks like just under 300, so it's that point. And this point here was just over 600, so it's that point right there. So what I'm going to do is write the coordinates of these points. 297, 211.50, and then the other point, 601, 44.95.50. Woo. All right, so now I have my 2 points. I've identified them. It asks me to find the slope between them. All right, so let's find the slope. Remember, slope B, y2 minus y1 over x2 minus x1. So again, this was my first point. Here's my second point. So I get 44.95.50 minus 211.50, all over 601 minus 297. So I have some calculations to do. Thank goodness for calculators here. So 44.950.50 minus 2011.50. So that top number is 2484. The bottom number, 601 minus 297, is 304. So I'm going to divide these two. So 2484 divided by 304. And I get my slope to be about 8.17. Okay. Now, I'm actually going to go to D and then come back to C. Okay. So D says, explain the real world meaning of slope. So remember how I like to define slope. Slope is for each, or for one each additional. Now I gotta put the X value. So if I go back up here, X represented tickets sold, or number of tickets. For each additional, or for one each additional, ticket sold, the Y value, so the Y value I believe was the revenue. The total revenue increases by $8.17. So here I'm actually comparing like number of tickets sold versus how much revenue I bring in for, say, some sort of concert. All right, so I'm going to jump back to C here. It says use your slope and one of the points to write the equation. So I have my slope, and I always like to use the first point. So I'm going to use that point slope form. Y equals the Y1 value, so 2011.50, plus the slope, 8.17, times X minus the X coordinate, or X1, 297. All right. So now what's nice is once I have this equation, I'm going to use it in part E. It says use your equation to predict how much revenue would be made if the concert sold out all 650 seats. So since the number of seats is like the number of tickets, that's the X value. I want to know how much revenue. That was the Y value. So now I just need to plug it into this equation. So I want y, it equals $2,011.50 plus $8.17 times 650 minus 297. So I get y2 equal. So 211.50 plus 8.17 parentheses 650 minus 297 close parenthesis. Hit enter, and I get a revenue of $4,895.51. All right, so the assignment, as always, worksheets, I apologize, those are from the old textbook. So use the rest of your time here today to complete the 3.3 worksheet. Have a great day.